Boa tarde.
Good afternoon. I'm going to ask if you're listening, if you can hear me halfway through the presentation, because I don't have a monitor and perhaps I ought to put headphones on. I'm Roberto, and I work in sales at Wacker. I have been there nearly 12 years working directly with silicon. But I also had some experience in the auto industry. I'm going to be talking about molding. I may be repeating some of what André said, but I'll be supplementing it. Let me go quickly through about what Wacker does, then I'll talk about silicon, and then I'll talk about some molding techniques. Wacker is a German company that's more than 100 years old. 110 years of love for chemistry, founded in 1914, and it's also on the Castelo Branco highway here in Brazil. That's Dr. Alexander Wacker, and he was an entrepreneur, and he was in his 60s when he founded the company. We are present all around the world. We have factories in Brazil, the US, Europe, and China, Japan, South Korea, and India, and commercial offices and technical development areas in a range of countries. Here is a bird's eye view of the main plant in Burghausen, Germany, near Munich. It's the main manufacturing hub. In Brazil, we have a plant in Jandira town of São Paulo, around about kilometer 30 of the Castelo Branco highway. To talk about silicon. Silicon is a rubber, but it's very different from any other rubber that you might think of, like natural rubber or polyurethane, because its chain is not a carbon chain. It's made of silicon or silica and oxygen. This gives it high heat resistance, so it can work from -50 up to 200 plus continuously without varying its mechanical, physical or electrical qualities. It's made out of quartz, which is mined. It's reduced in a charcoal furnace to silicon metal. Silicon metal, we produce silicon bars for solar energy, and some of it uses the Miller-Roschow process and producing chlorosilanes, distillation, hydrolysis, condensation to produce the polymer chain. Wacker consumes 7% of all energy produced in Germany just to carry out this 0.7%. These are the characteristics. We have high thermal resistance, and it is very resistant. You can make, for example, low melting point alloys. It's interesting because it's not viscous. You can get a lot of thixotropy, or you can get low viscosity, and it accepts pigmentation without changing color. The pyrogenic silicon is the main reinforcement. It does not get in the way in terms of lightness. There are two main cure principles. One is polycondensation, very similar to what André was showing us earlier, where there's no retraction on curing. And he was talking about polyaddition and then polycondensation, lower cost materials. The parts are more affordable in regard to that type of silicon, and when you need a more dimensionally faithful copy, then you can use polyaddition. Major properties of silicon. Viscosity is very important because this will dictate the level of copying faithfulness. For example, some applications are vertical and you need to add additives. so to adapt to the thixotropy of the material that you're working with. The pot life is mixing time. If you mix A and B, it will reach a viscosity. We usually measure it up to 100,000 millipascals per second. Handling time, minimum handling time, curing time, it varies. There are some formulations which are 2 or 6 or 8 hours, and there are some which have to be heat assisted. All of these properties and materials can be adjusted using a range of additives from to accelerate or break the thixotropy. These additives help with the process and can make your process quicker. Now, how to make the mold? I'm going to show you a very quick video. This is a standard one-piece mold for a prototype. Can you play the video? It's going to start from the master, which is a model. You have the mold, the container, scales, a silicon and a resin, and it's going to reproduce that piece. She's using plastiline to seal the lower part because it's going to be a one-block mold, a single part. She's mixing the silicon. This is 1-to-1, the mix. Some mixtures have different ratios, 9-to-1, 10-to-1. You have to look at the data sheet carefully. She pours it into the cavity and waits for the cure time. She's accelerating the cure time in an oven. Now to the demolding step. And she's demolded it from the model. Now we have the silicon mold ready for reproducing the piece. Now she's mixing resin. She homogenizes it. This is a piece of art work. A friend of mine bought a boomerang. He brought it back from Australia, and we bought the silicon by phone. It was in 1999, me and my friend, and we reproduced boomerangs for the whole neighborhood. It was very easy to work with silicon. You can make the pieces in a number of materials. It could be plaster gypsum, for example. Coating panels can be polyurethane. Some are good silicons for food molding. They're food contact or food grade. For chocolates, for example, ice creams, and also waxes, and also low melting point metal alloys, for example, pewter-based. The mold making techniques. The simplest method is what I showed, the block. I've got some pieces if you want to pass them around. This is being reproduced in plaster. It could be fiber, it could be resin. The advantages. The block mold is very simple. You can do it in a one-part or in a two-part technique. It's more complex, but every time you demold it, you have to be careful not to tear it or damage it, as you sometimes have to fold it.
Or in some cases of copy of texture of parts. You can do the casting technique to make a skin on the part to reproduce one part or two parts. And another techniques, vacuum to replace plastic in infusion, vacuum bags. Wacker started in 2012, was the main supplier of MVC for the molds or contra molds of the nacelles. Then there was a market. If you want to talk about it later, it's the material we still work with. And also silicone molds for vacuum casting, for prototyping in automotive, and white line mock-up of a design of a part. You can have parts that are functional. So vacuum bag is the main application for infusion. The main advantage in very fast building. In RTM, mold takes longer. It's more difficult. In silicone, with a couple of hours, you have this vacuum bag that will enable less use of resin. The quality of the end piece is much better. In the automotive industry, silicone for molding. One of the applications is in the design of surfaces and in the matrix of tires to copy foams in polyurethane and resin parts. When you look at the tires, it reproduces the part from the CAD so that you can do the cast piece. So it's easy to process, doesn't require expensive equipment, and it does an accurate copy because there is no contraction of the size. For tires, doing the molds, you go from a master of the tire, you adjust it, and you reproduce the same way as a silicone mold. You take a mold in silicone. You do the plaster core that will be cast so that you can have the matrix of the tire. And then they use the silicone so that you can use the mold of the tire. There are several rubber parts, and then it's inflated inside to design. It's very good. New design of tires. I showed you in the other slide. I skipped it, sorry. You saw the texture of the wheel. It's to do a shoe, to make a shoe, you use silicone to do the copy of the texture, and then you apply the resin and it goes to the oven, 230 degrees. Then you copy from the strips of the design to the shoe, entire shoe. In case of cars, you copy. In Brazil, it's not very common, but the vinyl of panels, dashboard. And last, to talk about Elastozil, that it's for vacuum casting. You use a two split mold and a vacuum to do casting of liquid resin or of an alloy of low melting time. It's used in white lines. In order to mold, to do the first mold for testing, you can do resin parts, plastic parts, so you can test it. It's interesting because it's an easy way, and the part is functional. It's the one you can use. In this line of products, we work Elastozil, M4641, and all these other numbers, 4644 in Brazil. It's self-exudating. On the surface, it's always wet, silicone oil, that it makes it easier for releasing from the mold. To do vacuum casting, it's very simple. You're going to do one part, as I have shown before on the video, and then to cut it because it's transparent. To cut the partition lines, to do the channels or the grooves. Then you fill the resin onto the mold in the vacuum chamber. For technical parts, automotive, white line, mock-up, prototyping. This is the last slide. This is the material if you want to talk to me. If you have a challenge to develop the molding with silicone, we'll be here until the end of the event. You can call me in WhatsApp, email, telephone. Thank you very much for your time. If there is any challenge, please count on us. Thank you.